Hey everyone, welcome back to another mind-bending physics dive. Today, we're tackling something super weird, the moon's orbit. You might think the moon spirals around Earth, as Earth zips around the Sunday. But that is totally wrong. Not only is it not a spiral, there is even an argument that the moon actually orbits the Sunday more than Earth. Let's break this down step by step. First off, from Earth's perspective, the moon does orbit us in a nice ellipse, but switch to the Sunday's view, or a distant star, and things get funky. The moon's path never curves outward toward Earth, it is always bending inward toward the Sunday, making its trajectory look like a smooth, almost circular loop with tiny nudges from Earth. Imagine it as a 12-sided polygon with gently curved corners, not some wild wiggle or spiral. To understand why, think about orbital mechanics in different reference frames. This kind of curve is called an epitrochoid, like those cool patterns from a Spirograph toy. It happens when one circle rolls around or rotates relative to another. Depending on the speeds and sizes, you get spirals if the inner circle is slow and small, loops if it is fast, or wobbles if balanced just right. But for the moon, its orbit around Earth is about 13.5 times per year, and the Earth-Moon distance is tiny compared to Earth-Sunday, about 1/400th. So, when you zoom out to real scale, the moon's path is basically a near circle around the Sunday, with Earth giving it small side-to-side pushes, like two satellites orbiting in tandem. No outward curves, because that would require the moon to be closer and faster. But Kepler's third law says farther objects orbit slower, square of the period over cube of the distance. Remember, doubling the moon's speed for a wobble would mean halving its distance, but then it'd crash into Earth, boom. Now, let's talk gravity. The Sunday pulls on the moon with almost twice the force Earth does, because the Sunday's mass is huge even though it is far away. Newton's law, force drops with distance squared, but mass wins out. So, the net gravitational force on the moon is always toward the Sunday, never away. But wait, why doesn't the moon just fall into the Sunday? Enter centrifugal force. From the whole system's motion, Earth and moon whipping around the Sunday together weakens that pull effectively. This puts the moon inside Earth's Hill radius, where Earth's gravity dominates for stable orbits, but outside the Chebotarev radius, where pulls are equal. It is a delicate balance. Plus, the Earth and Moon actually orbit their common center of mass, which is inside Earth since Earth is 81 times heavier. But if the moon were 40% farther or 6 times more massive, that center would pop outside, making us a double planet Lie.